Assalamu alaikum wa rahmatullahi wa barakatuh. You are welcome to the next edition of our online class, Chemistry for SS2 students. Last class, we started discussion on the chemistry of carbon. We have looked at the occurrence of chemistry of carbon, as well as the different forms of carbon that exist in nature. We also looked at the crystalline allotropes of carbon. I will implore you to go over the last lesson, so as to be able to refresh your mind. Today we are going to continue by looking at the amorphous forms of carbon. We have listed the amorphous forms of carbon in our flow chart in the notes that you received last lesson. The amorphous forms of carbon, as we noted that day, include charcoal, which can be subdivided into wood charcoal, sugar charcoal, and animal charcoal. We also have Lampblack and carbon black, as well as coal, as their amorphous forms of carbon. Today we will look at the different amorphous forms of carbon, their preparation, their properties, and their uses. The first one, as we have in the flow chart that you received during the last lesson, is wood charcoal, which contains mainly of cellulose. Wood contains mainly of cellulose, as you know. Therefore, when wood is heated in the absence of air, carbon is produced. You all know that cellulose is a polymer of glucose. Therefore, it will contain carbon, hydrogen, and oxygen. Even though there are some impurities in wood, and the impurity is mainly sulfur. So when wood is heated in the absence of air or limited supply of air, the black solid that is left behind, which in Yoruba we call eedru, is the wood charcoal. It is a black solid that is light, porous, and brittle. And because of its porosity, when it comes in contact with certain gases, it absorbs the gases, and its adsorbent nature increases with its porosity. If you want it to be more adsorbent, if you want to increase its adsorbent nature, we can convert it to activated charcoal. How is activated charcoal made? Activated charcoal is made by treating ordinary wood charcoal with steam. So activated charcoal therefore adsorbs more than ordinary wood charcoal. What are the uses of wood charcoal? It is used in making gas mask, because it can absorb the gases, unwanted gases from air. Fortunately enough, it does not absorb oxygen. So when you use wood charcoal in making gas mask, oxygen will be able to diffuse in, but many other gases cannot diffuse in. Specifically, some of the gases that are usually absorbed by wood charcoal include hydrogen chloride gas, ammonia gas, hydrogen sulfide gas, chlorine gas, sulfur oxide gas. Mostly poisonous gases, but it does not absorb oxygen, nor does it absorb carbon dioxide. Because of this, if you have a mixture of oxygen and ammonia collected over mercury, we usually, if we want to eliminate the ammonia from the mixture, we usually put activated charcoal on top of the mercury, so that the activated charcoal will absorb all the ammonia from the mixture, leaving behind pure oxygen. And to ensure that that happens, or to demonstrate that, the amount of mercury will rise in the gas jar to show that the gas volume has reduced. You know that there is no vacuum in nature. At the beginning of the experiment, from here to here is the volume of the gas, but as the charcoal absorbs ammonia gas from the mixture of gases, the volume of gas reduces. Therefore, the level of mercury in the gas jar rises, limiting the volume of gas, and that would now be oxygen gas, pure oxygen gas. Uses of wood charcoal continue. Activated charcoal is also used in the industry to treat water by filtering off suspended particles. It is used to remove unpleasant odor, unpleasant color, and unpleasant taste from water. All this ordinary wood charcoal can do, but not as much or as effective as activated charcoal. Sugar charcoal. Sugar charcoal is the purest form of charcoal. It is obtained when sugar, maybe the common sugar that we talk about, like sucrose, that is the table sugar, or any other forms of sugar like glucose or galactose or maltose, but most commonly used sugars are sucrose and glucose. When either of these sugars is heated in the absence of air, sugar charcoal is formed. Another thing that can be done to obtain sugar charcoal is by adding concentrated tetraoxosulfate acid to sugar, either glucose or fructose or sucrose. When that is done, the sugar is dehydrated. The concentrated tetraoxosulfate acid added serves as a dehydrating agent by removing elements of water from the sugar, leaving behind black deposits of carbon. As you can see in the equation, this is glucose. When heated in the absence of air, will form carbon, six atoms of carbon with 6 molecules of water. If the same glucose is treated with concentrated tetraoxosulfate acid, the same result will also be obtained. This is the formula of sucrose. When treated with concentrated tetraoxosulfate acid or heated in the absence of air, it will give 12 molecules of carbon and 11 molecules of water vapor. Next is animal charcoal. As you can observe, we called sugar charcoal because it was made from sugar. We called wood charcoal because it was made from wood. Similarly, animal charcoal is so named because it is made from animal remains, like animal bones or animal refuses. When either animal bones or animal refuse is heated in limited supply of air, we obtain what we call animal charcoal. You will remember from your knowledge of bones, chemical component of bone is calcium tetraoxosulfate. phosphate 5. So when bone is heated, the chemical component of bone still remains in the sugar charcoal. Therefore, so in the animal charcoal rather. Therefore, animal charcoal is rich in tetraoxophosphate 5 ions. Animal charcoal is a powerful decolorizing agent. Therefore, it is used in decolorizing sugar. When sugar is made from cane sugar, it is formed as bran. So incorporation of animal charcoal to bran sugar made from cane sugar decolorizes it to the white sugar that we have. It's also used in removing the color of indicators from solutions. If we titrate an acid solution with a base solution using an indicator, we get salt and water. In order to remove the color of the indicator so that we can easily obtain our salt from water in its purest form or in its purer form, we incorporate animal charcoal to remove the color of indicator. The next amorphous carbon that we are going to look at is Lampblack. Lampblack is made when hydrocarbon fuels are burnt in limited supply of air. We have all seen kerosene lamps as well as kerosene stoves before. If we light our homes using kerosene lamp, we will see black deposits that are greasy in nature, deposited below the wick, also on the shade of the lamp. All these are Lampblack. Also, if you check the exhaust pipe of motor vehicles, we will see black deposits inside. Those black deposits are Lampblack. So whenever hydrocarbon fuel is burnt in limited supply of air, Lampblack is formed. So these Lampblacks are also referred to as soot, and mainly it is used as fertilizer. Similar to Lampblack is the carbon black, though they are similar in nature, but they are not the same. Carbon black on their own are obtained when natural gas is very rich in methane. When natural gas is burnt in limited supply of air, the black deposits that is formed is carbon black. Carbon black is not as greasy as Lampblack, but it's also very fine black deposits. It is lighter than Lampblack and fluffy. In its own case, it is used in making the black pigment in paints. It is used in making black shoe polish. It is used in making the printer's ink, the ink that the printers use. It is the one that is used in making carbon paper, and it is incorporated into the use of vehicle tires of motor vehicles, either to color it or to remove or to reduce wear and tear in motor vehicle tires. The last amorphous form of carbon that we are going to talk about is coal. Coal is usually obtained from deep within the earth's crust. It is formed when plants in form of trees, especially woody plants, get decomposed under the earth's crust over a long period of time, like millions of years. Bacterial action, high temperature and pressure act on this wood, converting it gradually to what we call coal. During this process, some gases are produced along. So carbon dioxide is produced, methane is produced, and water vapor is also produced. This is why those that engage in coal mining usually encounter methane when they are mining. In fact, most explosions that occur in coal mining are caused by methane. Please take note of that. Most explosions that take place in coal mines during the mining of coal is caused by methane. When methane is being formed, some stages are passed through. First, the wood is converted to peat. Peat, after some actions of heat and pressure, is converted to lignite. Lignite later becomes bituminous coal. Peat forms lignite. Lignite forms bituminous coal. Bituminous coal is also called soft coal. And bituminous coal is later converted to anthracite. This process is called carbonization. That is converting wood to coal. That is making carbon from wood. It is called carbonization, and it takes place naturally under the earth's crust, but over a long period of years. In fact, coal is impure. It's an impure form of carbon and contains some impurities like nitrogen, phosphorus, and sulfur, NPS. Now, we are going to look at each of these products of the stages in carbonization. The first product is peat. Peat mostly is not referred to as coal because it is too soft, it is spongy, and can easily be compressed. In fact, it has high moisture content. So if we say it has high moisture content, it means it has low carbon content. So you have to take note of that. And therefore, for it to have any use, it has to be dried. And when it is dried, it is called dehydrated peat. And it is the one that is used as absorbent for oil spills. In oil producing areas, when petroleum is mined, you have spills of petroleum on the ground. Now to remove these spills, so peat are usually dehydrated peat is usually sprayed on the spills in order to absorb the oil. Now, after further action on peat by bacteria, heat, and pressure, lignite is formed. Lignite is otherwise called brown coal. It is the second product of carbonization, and it is often referred to as the first type of coal. It is very soft, as having lowest percentage of carbon, therefore highest moisture content among coals. It has peat has higher moisture content than lignite. But if we don't refer to peat as a type of coal, then the highest moisture content is contained among coals is contained by lignite. The next one is bituminous coal, which is otherwise called soft coal. When bacteria, heat and pressure further acts on lignite, then bituminous coal is formed. Bituminous coal is harder than lignite, but it is softer than anthracite. It has higher moisture content than anthracite, but less moisture content than lignite. It is used to generate electricity and also used to produce coke for steel industry. We are going to talk about coke later. Anthracite is the last type of coal, and it is the hardest form of coal, the one that can generate highest energy. When bacteria act further on bituminous coal with under high temperature and pressure, anthracite is formed. Anthracite is also called hard coal. It is very black and hard, having the lowest moisture content. In fact, the moisture content of anthracite is usually less than 8%, and it can generate a lot of energy. Therefore, it is used as fuel for domestic and industrial uses. This is where we are going to end our lesson for today. I pray Allah grant you understanding. Don't forget to check your portal for the assignments. Assalamu alaikum warahmatullahi wabarakatuh.